Ready? All right, I was just waiting for AV to get ready. It sounds like everything's ready, so I'm gonna get started. Hopefully you are all here for the Python talk because, yeah, I'm here to talk a little bit about how to write your own tools with Python. Who am I? My name is Nicolle Neulist. Most of you who know me probably know me as Rogue Clown because that name's a lot more fun anyway. It's just, slightly less professional if someone's trying to Google me. I don't know. Not like it's any secret. Anyway, I started learning Python about 4.5 years ago because I was just getting back into computers after a long hiatus of not playing around with them, and I was learning Linux and I was learning Bash, and I'm trying to be like, okay, can I learn something that's a little more cross-platform? And somebody suggested Python to me and started picking it up. I've picked up a few other languages since then, but as the most interesting man in the world says, I don't always write code that needs to work, but when I do, I write it in Python. Now, who are you? Some programming experience is helpful, but I'm not aiming this at someone who's been programming Python for years and years and years. The whole point of this talk is maybe you haven't done any Python, maybe you've done a little bit of Python but haven't had that much time to explore it, or you've gone to python.org, pulled up all of the standard library documentation and been like, oh my God, there are how many modules built into this language? Where do I start? Because that was kind of my reaction. I mean, I got through the basic Python tutorial of, okay, these are the data types, this is the syntax, you need colons, indentation, etc. But there's all this stuff that's built in, packaged in the language, and everyone says this is why it's so awesome, but it was kind of hard to know where to start. So I spent some time, sifting through Python books and looking at other code, finally found my way, but this is sort of intended as a roadmap to show you, okay, I want to start writing security scripts in Python. These are the modules that I'm going to need. But this is just a starting point. I'm not going to tell you everything there is to know about the Python language. I mean, an hour is just not enough time for that. I'm not going to tell you, all the possible scripts that you can make in Python. There's just not enough time for that. But what this will do is give you an idea of what kinds of libraries there are, what ones that I run into a lot, either in my scripting or when I'm trying to revise a script to make it a little more reusable or a little less confounding if I'm kicking it off to a friend for them to use. This isn't computer programming 101. I'm not going to go into all the theory of how to write a program, all the meanings of the different kinds of loops and data types. I'm going to go over them so you have an idea of the syntax when we get into the code examples. But it's not a detailed class, it's not a complete description, but it will give you a running start. Now, why do I program in Python? It lets me focus on my tool. I don't have to get bogged down in how am I going to manage the memory? What do I have to shove in this register or that register or the other? I mean, I'm kind of a dork. I think my favorite language to program in is assembly because I have fun getting bogged down in the little details of where every little thing is in memory. But that's honestly not practical. Let's say I'm, doing an online puzzle or a CTF or something. I'm not going to just start writing my script in assembly. By the time I have that done and debugged, the CTF is probably going to be over. Or, the gig that you're working on at work is probably going to be over. Your boss is going to be like, what? Where's my results? Whereas Python, it's high level, there's a lot of batteries included, and it just gets you focusing on, okay, how do I implement this idea that I have in my head? I love the syntax of Python. It's clear and it's readable. Even if you've never looked at, read a Python script before in your life, you can look at that and you can probably guess that it's going to print a verse of that awful, terrible Chumbawamba song from 1997. That top line there, #bang user bin Python, that just tells, this is the program that you need. It needs the Python interpreter. User bin Python is the normal Linux path for a Python interpreter. If it starts with just a hash and not the hash bang, that's just a comment. So I've got a comment there, tubthumping.py. In general, Python scripts end with .py. And then you've got a for loop, for booze in whiskey, vodka, lager, cider. They're in quotes, whether it's around single quotes or double quotes, it's still a regular old ASCII string. And that's just a list of ASCII strings. So it's gonna iterate through that list and print he drinks a blank drink. He drinks a whiskey drink, he drinks a vodka drink, he drinks a lager drink, he drinks a cider drink. And then, for the next part of that repetitive little verse, I got another for loop. For time in good, better. He sings songs that remind him of the good times. He sings the songs that remind him of the better times. That backslash there, if you're trying to keep your code within a certain width, like 80 characters or whatever, you can just break a string with a backslash and it goes to the next line. So I have that just because it had to wrap to the next line on my slide. One of the really nice things in addition is that it's cross-platform. It runs in Linux, it runs in OS X, it runs in Windows. Most Linux boxes have Python already installed on them. Mac OS X also usually has Python installed on it, although it's generally a bit out of date, so if you're running Mac OS X, you probably want to go to python.org, get the new one. Windows doesn't come with Python installed by default, but again, you can just get it installed from python.org and start running. It'll give you the Python interpreter, all of the modules in the standard library, as well as an IDE called idle. Yes, Python is named after Monty Python, so you've got, idle being the development environment. You pick up, the O'Reilly books on Python and all the examples are about spam and eggs. If you like Monty Python jokes, you're gonna really like the documentation of this computer language. Some modules may not run on all platforms, most of them do. You get to some things that are like lower level, like system or operating system type interactions. Some of it has been abstracted away. Most of it has actually, but some functions you'll go through the Python documentation and it'll tell you, this only runs in Linux, this only runs in Windows. If portability is one of your goals, like you've got a Linux box and you got a Windows box and you want to run your script on both, that can be an issue. It's just something to think about when you're doing your specific case of writing a Python program. Another thing I like about it is that it's an interpreted language with an interactive shell. That's just a terminal that I pulled off of my computer. I import the socket module, which is a module we are going to discuss in a bit of detail later because it is the lower level socket interface. It's how you open up and start talking to other machines. I did help socket and it doesn't show it there, but it threw up a screen of help about the module. Help is really nice. Like if you have a module and you don't really know how to use it, you can either go online to python.org and go through the standard library documentation, or you can just type help with the module name in parentheses at the shell, and it's going to give you a bunch of information about how to get running with that module. And then I get my host name. Yes, I call my computer Bucket. I'm a little obsessed with the walrus bucket meme. So, Bucket, Pale, Monazo's my server. Yeah, I'm kind of a dork. And then you can see there, socket.getHost by name. It throws an error. And one of the nice things about playing with your code in the interactive shell before committing it to a text file is it'll give you error messages that are usually pretty good about giving you an idea of what you screwed up. And you can test your code before jotting it down in your script file. So it tells me, it actually needs an argument. So I throw in an IP. It's not a name, it just spits back the IP. I throw in a host name, there we go. It gives me the IP address that resolves to that. So that's just kind of an example of bumbling through it in the shell. And if you're gonna program, if you've been programming for a while, you know this already. If you haven't, you're gonna learn fast. There's gonna be a lot of bumbling through. There's gonna be a lot of mistakes. There's gonna be a lot of going back. How is that formatted again? How is that set up? And if you're using a compiled language, you've got to read through it and look for the bugs and see it crash and have it tell you what line that the error is on because it refuses to compile. Whereas with Python, you can test it at the shell and it definitely lowers the amount of errors that I have going into even the first draft of my full script. Now that I've talked a little bit about why I like Python, let's talk about some of the basic building blocks of Python. Some of this you've already seen in the examples, some of this maybe you haven't. Python is a dynamically typed language. You don't have to declare that, variable test var is an int or a character or long or anything like that, like you have to do in, for example, C. It has all the data types that you'd expect from a computer language: integers, floats, long, complex. It uses J instead of little I for complex, but they work the same way as you may remember from high school algebra class. Don't know how much I remember from high school algebra class, but I sort of remember that. Strings are by default ASCII. It doesn't matter whether you have single quotes or double quotes around them, they're still ASCII strings. I've kind of come to the conclusion that it's a question of stylistic preference. I think the only time that I think that hard about whether I'm going to use single quotes or double quotes is if I have, an apostrophe, or if I have a double quote something within the string, I'll make sure to use the other one so it doesn't screw it up and I don't have to deal with escape characters. That said, I kind of like to keep, if I start using single quotes for a string in a script, I try to stay consistent with that. Sometimes it doesn't work out all that well, but Python doesn't care. If you want to use Unicode instead of ASCII, it's a U with single quotes. You can't do a U with double quotes, it's just a U with single quotes. I don't use Unicode that often, but there are some functions that do return Unicode. And if you, want to write a script that produces output with goofy characters, that's helpful. There are also sequential data types, lists and tuples. Lists are with square brackets, tuples are with parentheses. You can have anything you want as an item in a list. As you can see, list there, we've got strings, an integer. We've got a list within the list. And actually, I've got a typo in there. That last closed paren on list should be a second closed square bracket. I will fix that before I upload this slide deck to my site. And I'm really sorry for the typo. My point I'm trying to get at there is you don't have to have all the same data type in a list. You can have lists within lists. That's pretty useful if you want to do like a matrix or something. And you pull list elements by their element number. As you can see, list index 1 is 34. Python, like a lot of computer stuff, likes to start at 0, not 1. So like list 0 is the word this. The difference between a tuple and a list is you can change elements in a list, whereas you can't in a tuple. I could have something later in my code and declare that list 1 equals the word is, and it won't complain at me. It will just yank 34 out and put the word is in. Whereas a tuple, let's say I tried to say that tuple 2, instead of being leave me alone, was, let's say I'm going to change tuple 2 to a list of this 34, change me 1, 2, 3. It's going to yell at you and say that a tuple is an immutable object. So if there's a list of things, like for example, you have a function and it's returning multiple values, it will return those values in a tuple, and you can go through and put them in a list and change them in some other context. But functions return values in tuples because you don't want to go around, getting confused and thinking, oh, that function returned 5, when in fact it returned, this is the end of the world as we know it. There's also a mapped data type called a dictionary. Instead of doing just 1, 2, etc. as your indices, you can define the indices and the values that they map to, the key value pairs. File operations in Python are pretty simple. You define a file object by opening a file. You tell it the file path. It may be relative or absolute. That depends on how you plan on using your script. If it's one that you're just gonna throw in a directory and you don't care, you just want it to kind of throw the files into that directory or subdirectory, that relative paths are probably good. Whereas, if you know that it's going to be interacting with your Etsy password file on a Linux box, you're going to want to use the absolute path /Etsy/password. The flags are kind of important. That determines what kinds of permissions you're going to have with the file that you're opening. R is for read, W is for write, A is for append. Write and append, you kind of don't want to get those confused, because write is just going to start a new file. Whereas if you already have file text and you want to add more, you're going to want to use append. R plus is read and write permissions. B is binary. By default, it writes, just like ASCII text to a file. Linux doesn't care if you call it binary, because if it's binary, the Python in Linux is just going to say, oh, this is binary data. Right. Windows doesn't do that automatically. You have to define that. Although I think for portability's sake, as well as good practice for when you're bouncing between platforms, if it's going to be binary data, even on my Linux boxes, I will always put B for binary if I'm going to be accessing binary data. File reading functions, you've got file read, where your position, you start at the front of the file, and they'll read that many bytes and then move the file pointer there. So then when you go back, you can read the next 64 bytes and the next 64 bytes, for example. File read line reads the next line in the file from the file pointer. And read lines pulls all of the lines in the file into a list, one list element per line, which is useful. I use file read lines a lot. You've just got to be careful that you're not, trying to pull an 8 gigabyte file read lines when you only have 4 gigs of RAM. That's probably going to cause some problems. But other than potential memory problems, like file read lines can be great when you're just iterating through a text file at lines. File writing functions, you have file.write, and that will add that string, whatever you have as the argument to file write, into your file. Or file write lines. It's the writing corollary of file read lines. One line, you give it a list. Each item of the list is going to be a line in your file. I was talking about that file pointer before. Let's say you open a file, but you don't want to start reading it at the first byte. You want to start reading at the 128th byte. You use file seek. You can move it around, or you can move your pointer back to start, back to the end. And then file.close is pretty self-explanatory. You don't need to do it technically, like your file will automatically close at the end, but just for the sake of good practice, just to make sure I'm not being a total memory hog, I do generally put file close in my scripts. Control loops, it has all the loops you'd expect from a language. If, elif, else, while, for. I want to point out for is really nice because it's a very intuitive syntax. Like you have here, 4-character in string. It'll do something with the S, then something with the T, then something with the R. Like it treats the string as a list of characters. 4-element, you saw that in the little Chumbawamba script, does something with check, does something with out, etc. And then, if it's just a list of numbers, it's not going to make you write out a whole list of, 4-element in 1, 2, 3, 4, 5, ... 105, 106. You can just say for index in range 0, 10, and that's going to go 0, 1, 2, 3, 4, up to 9. So like I said, it starts at 0, but it's going to go 0 through 9, which means it will go through that range 10 times. Let's say you want to skip by 2. You could say for index in range 0, 10, 2, and it would go 0, 2, 4, 6, 8. Remember your indentations. Python does have a white space requirement, and I know this drives some people nuts, but I think it contributes a lot to the readability of the language. I would much rather go through somebody else's Python where at least I can look at the white space and be like, okay, these are the loop boundaries. The code on the side, on the left, isn't going to work. It's not indented properly for the blocks of if code. And you also look if item in list, there's no colon at the end. You need a colon to set off any kind of loop. Whereas on the right, if item in list, colon. The print that would, if item is in list, then print stuff 1 will happen and it won't crash. Elif other item in list, print stuff 2. One thing to notice there is that since it's, if, elif, which is, shortening of else if item and other item are both in the list, it's only gonna do item because it found it first. So you're gonna have to do a little bit different logic if you want it to do item and other item, like you'll need 2 loops. Defining functions. If you're calling the same bit of code over and over again, even in your little script, you're probably going to want to have a function. So instead of, writing those lines of code over and over again, you just send the argument and call it. Like for example, I've got this hex dump right here of a DNS query packet. And what if you're going to be just listening for DNS query packets, you're writing like a false DNS server or something, and you want to mess around with the query packets as they come in. You write a function. I've got it called extract name, DNS query. It's going to take the string of the hex of the DNS query packet. And then here it says address DNS packet brackets 13:5. You're gonna see this syntax a little bit, a few places in here. This 13-5 means start at the 13th character of the string and stop 5 from the end. Sorry, so I'm going back here. Sorry, I should probably take this with me. You've got, 0, 0, 1, 1, etc. You don't care about that if you're just trying to parse the text of the string. You care where it says www. That www is, 14, 15, 16, but Python starts at 0 instead of 1, so 13, 14, 15. You want to start parsing at the 13th. And then see those last 5 bytes, 0, 0, 1, 0, 1. Again, not text, not part of the address that you're trying to parse. So basically all that does is just cuts off the beginning and end that you don't really care about for this purpose and saves as the string that you're going to be playing with just what you care about. And then, as you can see there, you've got www.06, google.com in ASCII hex 03. So what you want to do is you want to replace 6 with a dot, 3 with a dot, and it's just going to return a string that says www.google.com. And it's going to work like that. And then query address, UDPS received from 1024. What receive from does is it gives you back a tuple, like I was talking about before, the immutable pair with the packet that it received and the address it received it from. Then domain name equals extract name query. Since I defined the first part of that tuple as query, you run that text through extract name, it's going to give you www.google.com or www.rogueclown.net or whatever the address is. So that's just a pretty short, simple example of a function that you could define in a script to play around with network data. Now that we've gone through kind of the base things in the language, I'm going to talk a little bit about modules. I love this XKCD comment because even though there's not actually an anti-gravity module that you can import for obvious reasons, there's a whole lot of stuff that you can import that you don't even need to download aside from the base language. What? I haven't actually tried that. I'll have to do that next time I fire up a Python shell. He said that it actually does drop a joke if you try to type import anti-gravity. Anyway, Modules are great because instead of having to re-implement socket communication, re-implement how to do, change mode, change group, etc., it's already been written. You don't have to do it again. Now, how you import the module determines how you call it later in the code. You can just type, import socket at the beginning, like you saw in one of my code snippets earlier. Then, whenever you call something from socket, you have to say socket.function with the args to tell Python that you're calling a function that comes from the socket module. Or you can say from socket import function, and then you just, call it the function. You would just say, receive from blah, as opposed to socket.receive from. If you're only pulling one function and you know that there's not going to be a collision between that and another function that you're using, like two functions that have the same name, from module import function is fine. Just be really careful before you do from module import star, because that imports all of them without the socket dot notation. And if the functions, let's say, you're importing from module 1 import star, from module 2 import star, if module 1 and module 2 have a function with the same name, how are you ever going to know if that function name is calling module 1 or module 2? You're not, and bad stuff's going to happen. How do you get modules? There are 3 ways to get modules from in your code. One is the standard library, which is the first one that we're going to talk about. 2 is the Python package index, which is a set of modules that other people have written that are not part of the standard library, but they are freely available. I mean, Python is open source software. These modules that you can get with easy install or pip are also generally free and open source software. Or you can import files in your working directory. Let's say you have a Python file, functions.py, and functions.py has a bunch of functions that you want to pull in and use in your other script. You can say import functions, and it'll pull in functions.py from your working directory. Standard library modules, go over a few that I use a lot in my scripts. One is sys. It's system-specific variables and functions that relate to the interpreter's functions. Things like the list of arguments that were passed to a command line script, or the path to the script, or sys.exit. That's one you're going to use a lot because let's say something happens and you need to close the program before it's over. You're in the middle of the loop and there's either an error or it's just sort of reached the end. You're going to want sys.exit. Although honestly, I don't use sys.argv a whole lot, even though I write a lot of command line scripts, because optparse is a heck of a lot better. If you're using sys.argv, you have to go through yourself and parse the switches from the arguments to those switches, and you have to do all that logic yourself. Like I said earlier, one of the nice things about modules is people have already done it for you, so why do it again? Optparse implements the logic for handling the command line switches. It gives you, help functionality, usage information, determining whether a variable is required or not, default values. I mean, it's just an easy way to make your Python script behave like any command line utility that you're already used to using. I generally do from optparse import option parser, and as we'll see later in this talk, I've got an example of a script that I wrote which uses option parser, and you'll see how the syntax goes. There's OS, which is higher level interfaces to operating system functions, file functions, user functions, permissions, environment variables. Most of the things in OS are cross-platform, not all of them. Subprocess. Let's say you want to call another program from your Python script. Subprocess call just runs it. In the parentheses, you would put the arguments that you need for the subprocess, and subprocess call just runs it. Subprocess check call returns the exit code for the subprocess. Subprocess check output returns, the text output, like what that subprocess would have printed to your console, returns in there, which is nice if you want to parse the output of another program while your Python script is running. Socket I showed a little bit before, but here's just a quick example of how socket works. You've got your, you import the socket module. I define a list of IP addresses, and S is just, your regular old TCP socket. AF, INET, sock stream. I mean, if you've done like much C programming, you've probably seen that, but basically don't get bogged down in the details. It's just a TCP connection. It iterates through the list, tries to connect to each IP address on port 80. S.shutdown2 means it's going to time out after 2 seconds. And if it's gotten anything back, it says it's up. Try except is just error handling. So let's say that it times out. Shutdowns after 2 seconds, nothing comes back. It's going to error out. The except block is going to catch it, and instead of printing error messages on the screen like you saw in the interactive shell help, it just says connection to host on port 80 timed out. Your program's not going to crash. Try except is really nice for that. Text matching. We already, as you could see, we did a little bit of text processing with the, cutting off of the bytes we didn't care about on that extract host name from a DNS query. Simple text matching, you don't need a module for it. As you can see there, if, /X is just a hex escape. So if FF, D8, FF, and hex are in the first 3 characters of some file binary, that's a magic number for a JPEG, and it's going to tell you file bin is a JPEG. If you need anything more sophisticated than that, like full-on regular expressions, you can import the RE module and get regular expression pattern matching. There are web libraries built in as well. It's nice because it puts some HTTP handling over the base socket module. You don't have to re-implement that yourself. URL lib2 is a set of methods for opening resources by URL. That's really nice if you're, if you kind of want to do like a wget sort of thing, just a line in your script that pulls a file down. URL lib is good. Also contains some methods for handling cookies, redirection, authentication, although we'll get into a module later called Mechanize that does that for you a lot nicer, just not in the standard library. If you want to hack on some lower level HTTP client functionality, HTTP lib is what it's called in Python 2. HTTP.client is what it's called in Python 3. They do the same thing. They're lower level. Generally not used, but you're hackers. If you want to do something lower level on HTTP, that might be useful. Crypto modules. There's like message hashing stuff in the standard library. MD5, SHA, HashLib, HMAC. There aren't public key cryptography modules though. So if you want to do any of that, there are outside modules. One is called PyCrypto, one is called RSA Python. But because of all the, nasty legal malarkey about, you can't export this or that kind of crypto, they've just decided to stay the heck out of it and not put the public key cryptography modules in the standard library. So now we're just going to look at a tool that I wrote that uses only the standard library, just to kind of see some of this in context, because I know I've thrown a bunch of Python stuff at you. MS SQL auth encryption sucks a lot. It just expands the password to Unicode format, swaps the first 4 bits with the last 4 bits in each byte, XORs it with A5, and there you go. So if you're, sniffing packets, something A5, something A5, something A5, like I saw in this puzzle that I was doing online pretty recently, yeah, you've probably got, and it says there, it's nice, Microsoft SQL Server Management Studio. Username is in plain text, transaction. All you have to do is decrypt the password. And well, that encryption sucks. So there's the beginning of the script. I've got from opt parse import option parser, from sys import exit, and then import RE, which is the regular expression module. The usage string just says usage program -I import file -O output file. It's the kind of help string that you would see if you were running a Linux kind of command line utility. And then you create an instance of the option parser, and then parser.add option -I. I'm sorry, I think the red is a little hard to read, and I'm really sorry about that. I will have my slides up so you can look at it in detail. I'm just trying to talk my way through it so y'all know what I'm getting at. Vim likes to put my strings in red, and I actually don't really use idle all that much. I edit my text in Vim generally. So you define -I, which is the short, -- input, which is the long. Means the same thing though, it's just the switch. Dest is the variable it puts it into, so it puts the input file in input file. Because basically the way this works is you can define a file in, like with a list of these hex dumps, and then it will put out either in an output file if you define it, or in a, just to the screen if you don't do an output file. It'll give you the cracked passwords without you having to go through all that XORing yourself. Defines it as a string, and then there's a help string that just says, file with hex strings of encoded passwords. 1 hex string per line. Default takes strings from standard in. And then the second option is file out. And then that ops, args equals parser.parseArgs. That's just telling the option parser module, okay, look at the line, look at, what was given as -I, -O, etc., and parse it for me. Then it handles the input. If ops.infile, as in if there's an input file that was defined, it takes in, opens the file with read permissions, reads the lines into a list of hex strings, closes it. If it can't open the file, it says error opening file, and there's that sys.exit function. It exits with an exit code of 1, you had an error. If there was no input file defined, then I just define hex strings as an empty list and append to it raw input, which is just the user input at the keyboard function, enter SQL authentication hex bytes to crack. And the reason that I did it as a list as opposed to just a string is because the way I define my functions later in the code, as you'll see, it iterates through each set of hex in the string to crack the passwords. Speaking of cracking the passwords, there's the function to decode the password. It takes one string, because it's later in the program, like this is just a function, this isn't the main code. In the main code, it's called, it iterates over the items in the list of hex strings. It strips all of the white space, that's at re.subline. Strips all of the white space, then, while it iterates over the characters in that, puts it into bytes. It takes the string, makes it a list of hex bytes. And then all of those characters equals, that's just going through and reversing that cruddy encryption of the password. The one thing to point out there is you've got characters, and then you see those list brackets, and there's some kind of function for character in character. Oh God, that's loud. Some kind of function for character in characters, which is a list comprehension. A list comprehension is just a funny name for take a function, do it to everything in that list. And then I save it back into the original list, and once I've fiddled around with all those variables, it comes back, return password. It gives the cracked password. These are some functions that are called within the function, one that just pads some stuff with zeros, one that's the function that actually flips the second nibble with the first. Main functions, as you can see there, passwords is a list, and then for hex string in hex strings, which is why even when you just enter 1, it was a 1-item list. It calls passcrack on that string and appends it to the list of passwords. And then below that, if it's defined as an output file, then it writes line by line, this is the hash, this is the password, this is the hash, this is the password. Else, it prints it to the screen. This is just, not using any input or output files. You call it, it asks for the bytes. I put the bytes, I kept the space from the packet dump because I know that it would strip them out for me. Then it prints the dump, blah, A5, blah, A5. And so 9.3, A5, B3, A5, etc. is just the word cactus in cruddy SQL authentication. that only used functions in the standard library. But there are a couple of things that are outside of the standard library that you're probably going to want to use. And now this is all freely available, open source software that you'll have no problem getting. Seriously, just Google any of these modules, you'll be good. One is called Mechanize. I mentioned earlier that that URL lib had some cookie handling functionality, authentication handling functionality. But Mechanize is awesome because you instantiate one of these browser objects. You can set it to manage your cookies for you. Set how it manages like zipping, redirecting, refreshing, how much debug it's going to print for these connections. You can fake your user agent string, and this is all built into the module for you. And then here, click the link. You have your browser item that you instantiated with that previous code. And you go through, look for any specific, I have regex there is just like what you're looking for. It's not always a regular expression, it can be just a string. And look for it, follow the link, because it's got that nice follow link, you click it and it goes there. If it doesn't find it, you can make it complain. But this is just a nice, easy, high level, how to script a web browser session. Scapy is another module that I absolutely love. Like, you could probably do several talks on just it. It's how you build packets in Python. Even though it's not in the standard library, if you have backtrack 5, it is on backtrack 5 by standard. You can just run Scapy and it will pop you up a Python shell with Scapy already imported. Or you could just start using import Scapy in your scripts. It treats packets as protocol layer over protocol layer over protocol layer. So as you can see, I just have a simple like ARP pinger here. It's Ethernet over ARP. You set the destination to FF, etc. Broadcast. You set the destination, so you can say, okay, I want to try to get ARP on all of these hosts in this subnet that I'm already on, and then it returns a list of packet objects. This is it running. It sends out all of the packets, and then it gives answered and unanswered. The SRP is the Scapy function to send out the frames on layer 2 with a timeout of 3 seconds, and then any IP address that answers any IP address that answers with a MAC will end up in the answered list. Anything that doesn't, unanswered list. So it lets you sort your results really nicely. Again, it's logic that's already been written for you, so you don't have to. You dump the summary. Again, that's just a built-in function in Scapy. It tells you which IP addresses are taken and what MAC addresses are at those IPs. Obviously, you can do stuff a lot more sophisticated than that with Scapy, but that's just a pretty basic example of getting up and running, how to build a packet with multiple layers, how to change some of the defaults like the IP address and the MAC for broadcast. You can sniff packets. There's a sniff function. That one liner there will sniff the first 10 packets of ICMP, count 10, L filter, has layer ICMP. And it puts them in a list called packet list. You can use it to read and parse existing PCAPs. It's got to read PCAP and write PCAP, so you don't have to rewrite all of the file logic to deal with specifically PCAPs. Scapy does that for you. It has help in the shell as well. It's a little different than the regular just Python help. LS lists all the packet classes, so if you're trying to figure out, okay, how do I build a TCP packet that has this, that, and the other attributes? LSC lists all of the available functions, and then it still does have the help function for specific functions, but it knows that, your first question is probably going to be, well, what functions does this have? that's kind of the end of this whirlwind tour of Python. If you're interested in learning more, learning Python and programming Python, which are the O'Reilly manuals, are really good. I mean, that's how I learned the language to start. Coding for Penetration Testers by Jason Andrus and Ryan Lin. I think both of them are actually wandering around here at DerbyCon. I love that book. It covers Python and a bunch of other languages in amazing detail and gives you a lot of context for how to use languages in security scripting. Gray Hat Python is a lot of fun, especially if you want to do exploit dev or fuzzing. Security Power Tools, chapter 6 is an entire chapter on Scapy, which is awesome. There are also online resources. The official Python tutorial, which is just kind of a get you started and running with the syntax of Python. The standard library reference, that's the link to the project page for Mechanize. And then below that is the project page for Scapy. So if you want to read about it in more detail before you get your feet wet with the code, those are good places to go. Anyway, thank you for coming. I have a little time to take questions now. Otherwise, you can harass me by email, website, Twitter, find me at the con. Thank you. I saw a hand up in the back. He asked, there's a module called requests that allows you to form get and post requests, and asked if I had more control over it with urllib2. Yeah, you have a little more control over it with urllib2, but honestly, for sending get and post requests, requests is a lot cleaner and a lot nicer. That's actually a good point. That's another module. It's outside of the standard library, but it's freely available, and it's definitely a lot cleaner than building the get and post requests from urllib2. I mean, sometimes I use requests, sometimes I use urllib2. It depends on my mood and depends on, if I really need to deviate from the functionality that requests gives me. Yes? One of the issue with, I'm not sure about proxies specifically. The issue with HTTPS is sometimes SSL is compiled with a Python install and sometimes it's not. And if SSL is not compiled with your Python install, urllib2 is not going to be able to handle HTTPS. It will only be able to handle HTTP. So if using SSL, if using HTTPS is a deal breaker for you, you need to make sure that your Python install is compiled with SSL support. Any other questions? Thank you all for coming.